The equation x over x equals 4 has no solution, but the equation x equals 4x does. These equations they seem to be one step away from each other, but that step can come with a hidden assumption, and that one step is all it takes to enter a path of confusion. They're called domain restrictions, and they are quite easy to deal with. If you were looking at the equation, then you'd notice that 0 is a real answer to the first equation, x equals 4x. And you can see that if we plug in x equals 0 to the second equation, it doesn't logically follow. So it is algebraically true that the first equation has a solution while the second one doesn't. So the question shifts to, can we transform two equations into each other? Let's take the first equation, x equals 4x, and then just divide both sides by x to get the second equation, right? And that works. If x is 5, you could divide both sides by 5 while maintaining equality. Divide both sides by -2 while maintaining equality. But that doesn't work when x is equal to 0, which we have shown in this case is the only real solution. So when you divide both sides by x and x is equal to 0, then you're implicitly dividing by 0, which is an illegal maneuver. What about the second equation? Starting with x over x equals 4, can't we just multiply both sides by x so that it's the same as the first equation, the one with the answer? Yes, however, if it's done incorrectly, you can lose information. X over x tells us that x cannot be 0, and that information isn't present in the second equation. So we can include that information using a special notation, turning x over x equals 4 into x equals 4x, comma, x cannot be 0. Writing this domain error alongside the equation means that no additional information was created and no information was destroyed. So yes, those two equations are not equivalent. And it feels wrong because it looks like it's just one operation away. But the operation that you want to do is either illegal or there's a loss of information. Math isn't doing you wrong. You're doing math wrong. We could look at the different representations of these functions. Here is the one with the solution, x equals 4x. We could see that they intersect where x is equal to 0. So that's a valid solution. And then we could look at our original second equation, x over x equals 4. It would look something like this. We graph 4, which is just a straight line where the height is 4. And how would we graph x over x? Well, 3 over 3 is 1, 2 over 2 is 1, 1 over 1 is 1, negative 1 over negative 1 is 1. So it's a straight line, but where 0 over 0 is, there's just a hole. And then let's go to our modified second equation, x equals 4x, and x cannot be 0. We see that it looks exactly the same as the first equation, except where they should intersect, there's a hole there, because it's outside the domain. Many operations have domain errors, and it's helpful to think of the graph to visualize where those domain errors lie. Face reveal at 10 subscribers.